Imagine looking up tonight and finding an empty patch of sky where the moon should be. No explosion, no fragments. The moon has simply vanished, as if someone erased it from the universe. This impossible scenario breaks physics, so we need one rule. The moon disappears without transferring its energy anywhere. Under that rule, Earth would not suddenly crack apart, and people would not fly into space. The first obvious change would be visual. Night would become much darker whenever artificial light was absent. Moonlight is reflected sunlight. Remove the moon, and that familiar silver illumination disappears with it. There would be no crescent, no full moon, no lunar eclipse, and no moonrise on the horizon. The stars would appear more prominent from dark locations, but the sky would lose its largest nighttime landmark. The gravitational change would be less cinematic than most disaster films suggest. Earth would continue orbiting the sun. The sun contains almost all the mass that controls our planet's yearly path. The small monthly wobble of the Earth-Moon system would end, but the planet would not shoot out of the solar system. The biggest immediate physical effect would be the tides. Lunar gravity pulls differently on the near and far sides of Earth, stretching the oceans into tidal patterns. Real tides are complicated by continents, ocean depth, coastline shape, weather, and Earth's rotation. But the moon is the dominant astronomical influence on Earth's tides. Without it, tides would not vanish completely. The sun also produces tides. Solar tide generating force is roughly half the lunar contribution, so many tidal ranges would become substantially smaller. The exact result would vary from place to place because coastlines turn simple forces into complex local rhythms. Some harbors would see modest changes. Other shores that depend strongly on lunar cycles would be transformed. Intertidal ecosystems live in the moving boundary between land and sea. Smaller tides would alter when mudflats are exposed, how nutrients move, and which organisms can feed there.
Animals adapted to precise lunar and tidal schedules would face a rapid environmental shock. Many corals coordinate mass spawning using a combination of temperature, sunset, and lunar cues. Remove one of those cues overnight, and synchronized reproduction could initially fail for some species. Evolution could eventually favor new cues, but ecosystems cannot redesign themselves in a single season. Moonlight also changes how many nocturnal animals hunt, hide, travel, and communicate. Some predators see better on bright nights. Some prey reduce activity because they are easier to spot. A permanently moonless night would therefore help certain species and disadvantage others.
Humans would compensate quickly with electric lighting, navigation systems, and revised coastal predictions. Wild ecosystems would have no such instant replacement. The moon's slowest and most profound influence involves Earth's axial tilt. Earth is tilted by about 23 degrees, and that tilt creates the seasons. The moon helps keep that tilt within a relatively narrow range by changing how Earth's spin axis precesses. If the moon vanished, Earth's axis would not topple tomorrow. The change would unfold over extremely long timescales. Over millions of years, gravitational interactions with other planets could allow much larger and less predictable tilt variations.
That could make future seasons far more extreme, moving intense summers and winters into unfamiliar regions. The classic research describes a broad chaotic range, but later modeling adds an important caution. A moonless Earth might still remain habitable because major tilt changes could be slow enough for life to adapt. So the honest answer is not instant climate apocalypse, it is much greater long-term uncertainty. The moon has also been slowing Earth's rotation through tidal friction for billions of years. As energy moves through the Earth-Moon system, our planet's day lengthens extremely slowly. Remove the moon, and most lunar braking disappears, although solar tides would still exert a smaller effect.
The current 24-hour day would not suddenly become shorter. It would simply stop lengthening at the same rate. Ocean mixing would change as well. Tides move enormous volumes of water through coasts, shelves, and narrow channels. Reduced tidal energy would alter local mixing, sediment transport, and nutrient exchange. The outcome would not be identical in every ocean, and it would not switch off the entire global circulation. Technology in orbit would mostly keep functioning, but precise trajectories would need new calculations. There would be no lunar missions, no future moon bases, and no natural stepping stone beyond Earth. Calendars and language would change more slowly. Months, festivals, stories, and symbols carry lunar history.
Cultures would preserve the memory of a world that once had a bright companion in the night sky. It matters how the moon disappears. If it shattered into debris, the scenario could become catastrophically different. Our thought experiment uses clean disappearance, so we can isolate what the moon quietly does for Earth. During the first day, people would notice darkness and confused predictions more than planetary destruction. During the first year, coastlines, wildlife, astronomy, and culture would begin adjusting. Over centuries, smaller tides would reshape some coasts and ecosystems. Over millions of years, the missing stabilizing influence could transform Earth's seasons and climate patterns.
The moon looks passive, but it is a quiet architect of tides, night, biology, rotation, and climate stability. If it vanished, Earth would survive the night. The deeper transformation would arrive slowly, one tide and one orbit at a time.